So let's see how we did, folks. So we have here a mass and a volume, and we know density is mass to volume, and there's different ways, different units that we can measure density, but most of the time in this class we're doing it as grams per milliliter, which gives us an initial issue we need to address, is that this is in kilograms, so we need to convert it to grams. We have our volume in milliliters, but we can't do kilograms to milliliters. That's not a standard way of measuring volume, density, and I did state very specifically I want it in grams to milliliters. So we know that every kilogram has 1,000 grams, so kilo literally means times 1,000. So we multiply 32.479 kilograms times 1,000 grams per kilogram. We can do this dimensionally. We cancel out the kilograms if you're into that. And we get 32,479 grams. Now we can plug it into the representation formula that we want for density of grams to milliliters. And we come out with a raw value of a number that just goes, it's an irrational number, just goes on and just irrationally to infinity, 376.349942.06257. My calculator kept going on past that. That, of course, is very unrealistic because we don't have any sort of scale or graduated cylinder that's measuring to those levels of accuracy. That makes no sense. So we need to measure, we need to round to the levels of reflects the levels of measurement. We were able to, we have 5 significant figures here, and then here we have only 3. So we have to reflect that. Now when we add numbers together and when we're dealing with significant figures, we round to the least number of decimal points. However, multiplication and division are rounded differently because multiplying and dividing, to use the way it's described often, is you're compounding error more when you're multiplying and dividing than when you are adding and subtracting. So when multiplying and dividing, we round to the least number of significant figures, not the least number of decimal points. So here, we have, for this number, we have 5 sig figs. Whereas right here, this volume, we have 3 sig figs. So it makes sense when we have 5 sig figs and 3 sig figs, we will round to 3 significant figures. That's what we do in a multiplication or division problem. So this is not only how we convert values so we can do the correct mathematical operation, but how we actually round our product in a way that realistically reflects the accuracy of measurement of the values that went into the problem. And once again, this comes back to honest reporting of scientific data. Good luck and congratulations if you got this problem right. If you didn't, we're going to try to do one of these almost every week. Try again. There's no reason not to at least try. So let's get off to a good start and really try to tackle these significant figures and rack up some bonus points.